In this video, we are going to continue solving this past paper, which is the Science Paper 1, 2022 internal. So the last time we had this paper, we ended on question B3. So today we are starting from question B4. Question B4A, the question reads, two successive crests of approaching water waves are separated by a distance of 1.8 meters. It takes 0.3 seconds for one crest to cover the distance of 1.8 meters. At what speed is the wavelength traveling? At what speed is the wavelength traveling? Okay, so we are going to look at the wavelength. So the wavelength is the distance between two crests. So the wavelength is the distance between two crests. So this is the distance we are talking about. So the 1.8 meters is here. Okay, so it is the distance they are talking about, or we can say the wavelength is the distance between two trophies. The distance between two trophies. Okay, let us come back to the question. So what are we going to do? So the first thing that we are going to do to answer this particular question is to come up with the formula, the speed formula. So we are going to say speed is equal to distance over time. Speed is equal to distance over time. Therefore, we need to know the distance and we need to know the time. Data collection. So distance is equal to 1.8 meters. Time is equal to 0.3 seconds. So therefore, we are going to say speed. We are going to say speed is equal to where there is distance, we are going to write 1.8. Okay, then where there is time, we are going to write 0.3 seconds. 0.3 seconds. So if we do calculations, we are going to get 6. So speed is equal to 6 meters per seconds. Speed is equal to 6 meters per seconds. So therefore, we are going to say speed is equal to 6 meters per seconds. We shift to the next question, which is question B4. Question B4, the question reads, sorry, the question B4 Roman numeral 2. Question B4 Roman numeral 2, the question reads, what distance is covered by the wave in 2 minutes? What distance is covered by the wave in 2 minutes? So what formula are we going to use here? So even this one, on this one, we are going to use the speed formula. So we are going to say speed is equal to distance over time. So what have we been given according to question A, Roman numeral 2? So we can see that we are given time, which is 2 seconds. We are given time, which is 2 seconds. What else have we been given? We also have speed. So we use the same speed, which is 6 meters per seconds. So therefore, we are going to say data collection. So speed is equal to 6 meters per seconds. Time is equal to 2 minutes. So okay, so in order to find the distance, we need to convert our time in 2 seconds. So as we can see, the speed we calculated is in seconds, meters per seconds. So therefore, let us convert 2 minutes to seconds. So we are going to say we are going to say 60 seconds. 60 seconds make 60 seconds make 1 minute. 60 seconds make 1 minute. Now what about 2 minutes? So 2 minutes here we are going to write here we are going to write x. Here we are going to write x. Then we do a close multiplication. We do a close multiplication. So we are going to say x times 1 is equal to x. X times 1 is equal to x. 60 times 2 is equal to 120 seconds. 120 seconds. So 120 seconds, we have successfully managed to convert the time. Yeah, successfully managed to convert the time. Now the let us find the distance. So to find the distance, we are going to say where there is speed, we are going to write 6 meters per second. Then where there is distance is what we are looking for. Then where there is time, we are going to write 120 seconds. Let us do a close multiplication. We do a close multiplication. So we are going to say 1 times d representing distance is equal to d. 6 times 120. 6 times 120. 6 times 120 is equal to 720. Is equal to 720. So here we are going to get 720 meters. So 720 is our answer here. So therefore our correct answer is 720. We shift to the next question, which is the question B4B, Roman numeral 1. The question reads, calculate the frequency of a sound wave with the speed 340 meters per second and wavelength 0.5 meters. So we said wavelength is the distance between two crests. So wavelength is the distance between this crest and this crest. So this is called the wavelength, and the symbol that we use is this one. Okay, so we are taught to find the frequency. So the formula that we are going to use to find the frequency, we are going to say frequency is equal to velocity over wavelength, or we can say frequency is equal to speed over wavelength. Okay, here we are given the units of the we are also given the units of the wavelength. So therefore, the first thing we are going to come up with the formula, then data. What have we been given according to our question? We are given velocity, or we are given speed. We are also given the wavelength, which is 0.5 meters. So we are going to say frequency is equal to where there is v is representing velocity or speed. We are going to write 340 meters over where there is wavelength. We are going to write 0.5 meters. So if we say 340 divided by 0.5, we are going to get 680. So here we are going to get 680 is 680 is. So this is our answer. So therefore our answer here, we are going to say 680 is. We shift to the next question, which is the question B, which is question B4B, Roman numeral 2. Could this sound with the frequency calculated in B, Roman numeral 1, be heard? So to know if this sound can be heard, we are going to look at the normal human hearing range. So here we have the human hearing range. So a human can hear a sound between 20 Hz to 20,000 Hz, or to 20 kilohertz. Kilo means 1000. So since 680 Hz is within the range, we are going to say yes, the sound can be heard, or the sound is audible enough. Justify question 3. Justify your answer. Justify your answer. So to justify our answer, we are going to say it is within human hearing range from 20 Hz to 20,000 Hz. So we are done with this question. Now let us shift to the next question, which is question B5. Question B5A, the question reads, infrared and radio waves are components of electromagnetic spectrum. B5A, Roman numeral 1, mention one use of infrared radiation and radio waves. So we are given infrared and radio waves. Okay, so we need to understand that infrared are used in remote controls. Infrared are used in remote controls. So therefore, we are going to say they are used in remote controls. Radio waves are used for communication purposes. Radio waves are used for communication purposes. So because of the radio waves, our radios and our TVs are able to receive signals. So therefore, we are going to say are used for communication purposes through radio and television signals. Through radio and television signals. We shift to the next question, which is question B5. Question B5A, Roman numeral 2. Mention one common property of infrared and radio waves. So the members of electromagnetic spectrum, or the components of electromagnetic spectrum, they have got properties they share. So they are all light in nature. They are light in nature. Or let me say, they possess some of the characteristics or the properties of light. So members of electromagnetic spectrum, or the components of electromagnetic spectrum, travel at the speed of light in the vacuum. They travel at the speed of light in the vacuum. Or we can say the members of electromagnetic spectrum, they are light waves in nature. They are light waves in nature. And we know that, okay, so we are just going to say, we are going to say they all travel at the speed of light. They all travel at the speed of light. So they all travel at the speed of light in the vacuum. The next question, which is the question B5A, Roman numeral 3. Give one amp effect of electromagnetic waves. So electromagnetic waves may cause cancer. So prolonged exposure to electromagnetic waves may cause cancer. Okay, so we can see the cells being disturbed here. You can see cells being disturbed, leading to tumor, cancer. Okay, so therefore we are going to say the electromagnetic waves may cause cancer. Electromagnetic waves may cause cancer. Question B, question B5B. Question B5B, the question reads, Give one difference in propagation between sound waves and electromagnetic waves. So there are two types of waves, transverse wave and longitudinal waves. So particles in the longitudinal waves travel. Here we can see that sound wave is an example of a longitudinal waves. Then light wave is an example of a transverse wave. So how do particles move or propagate in the longitudinal waves? So particles in the longitudinal waves move parallel to or from the direction of the waves. So here where we can see squeezed, where we can see squeezed or compressed, where we can see squeezed or compressed lines. So this region is called compression. Then where we can see lines that are spacely packed, this region is called rarefaction. Then particles in the transverse wave, particles in the transverse wave propagate or move parallel or perpendicular, sorry, they move perpendicular to the direction of the wave. So we can see the direction of the wave and the particles are moving perpendicular. So in the transverse wave, particles propagate perpendicular to the direction of the wave. So we can see these pink arrows are showing the propagation of particles. Then we have a longitudinal here. We can see that the particles are moving parallel to or from the direction of the wave. So the the the, the, here we can see that the waves are spatially packed, and this region is called rarefaction. This one is called uh, compression. So here where waves are squeezed together is called compression. Here where waves are spacely packed is called rarefaction. Here compression, 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 rarefaction, rarefaction. So therefore we are going to say, so in order to give enough information, let me reduce the font size of the we are going to say the particles of sound waves propagate or move parallel to or from the direction of the waves, while particles of the magnetic waves propagates perpendicular to the direction of the wave. So we have answered this question. Let us move to question B5C. Question B5C, the question reads, mention one factor that affects the loudness of sound wave. So amplitude is one factor that affects the soundness of the wave. Okay, the soundness of the wave. The last part of question 5. So we are going to end on question 5 in this video. Question 5D, the question reads, a learner sees a flash of lightning and hears the thunder after 4.5 seconds. How far is the lightning from the learner? Take speed of sound in air to be 340 meters. So the first thing we are going to come up with the we are going to come up with the speed formula. So speed is equal to distance over time. Data. So we are given the speed, which is 340 meters. We are also given the time, which is the 4.5 seconds. Okay, now let us find the distance. So to find the distance, we are going to say distance, we are going to say speed. Okay, we are going to say speed is equal to distance over time. is equal to distance over time. So we are given the speed, which is 340 meters per second. We are also given time. We are given time, which is 4.5 seconds. So let us do a cross multiplication here. We do a cross multiplication. So we are going to say 1 times distance is equal to distance. So 340 times 4.5, we are going to get 1530 meters. 1530 meters. So this is our final answer. So therefore our correct answer here is 1530 meters. So this brings us to the end of this video. 530 meters.